In this lecture, I am going to discuss on the topic T parameters of two-port network. T parameters are also known as ABCD parameter. The T parameter or ABCD parameter is used to represent transmission line in electrical system. T parameter or ABCD parameter is another set of parameters which relates the variable at the input port and the output port. T parameter is also called as transmission parameters because these parameters are useful in the analysis of transmission line. See, in the transmission line, it has sending end and receiving end. At the sending end, there is sending voltage and sending current. At the receiving end, we'll get receiving end voltage and receiving end current. Considering this fact, we can represent the transmission line into an equivalent model by using the ABCD parameters. The figure shows a two-port network which is represented by ABCD parameters. Here in the figure, at the input port, we are getting voltage V1 and current I1. At the receiving end, for the port 2, we are getting voltage V2 and current I2. Here we are taking I2 as negative because in transmission line at the receiving end, normally a load is connected where the output port as load is connected, the direction of I2 is opposite to the standard notation. Here sending end voltage V1 and sending end current I1 is expressed in terms of output voltage V2 or receiving end voltage V2 and receiving end current I2. So V1 is expressed as V1 equal to AV2 minus BI2, which is shown in equation 1, and I1 is expressed as I1 equal to CV2 minus DI2, which is shown in equation 2. In matrix form, we can write V1 I1 equal to ABCD matrix into V2 into minus I2. Now to calculate the value of ABCD, we have to make two conditions. In one condition, I2 equal to 0 and in another condition V2 equal to 0. To make I2 equal to 0, output port is open circuit, and when V2 equal to 0, output port is short circuited. See from this figure, from equation 1 and 2 we will get the value of ABCD parameters. So from equation 1, see, when we want to calculate the value of A, we have to make this part 0. To make this part 0, we have to make I2 equal to 0. I2 equal to 0 means we have to open circuit the output terminals or receiving end. So by making open circuited the output terminals, we can calculate the value of A and C. To calculate the value of B and D, we have to make V2 equal to 0. V2 equal to 0 means output terminals are short circuited. We have to short circuit the output terminals to make V2 equal to 0. When V2 equal to 0, we are getting the value of B and D. So A equal to V1 by V2 when I2 equal to 0, C equal to I1 by V2 when I2 equal to 0, B equal to V1 by I2 when V2 equal to 0, D equal to I1 by I2 when V2 equal to 0. Here A and D are unitless and B has unit ohm and C has unit Siemens. Here one two-port network is shown. From this figure we have to calculate the value of ABCD parameter. See, it is a two-port network, sending end voltage V1, sending end current I1, receiving end voltage V2, receiving end current I2. So to calculate the value of A and C, we have to open circuit the output terminals so that we can make I2 equal to 0. So by open circuiting open circuited the output terminals, the circuit is reduced to this network. So from this network we can write V2 equal to 10I1. V2 equal to the voltage drop across this 10 ohm resistance. So V2 equal to 10I1. So C equal to I1 by V2, it is equal to 0.1 Siemens. So from this equation we can also write V1 equal to 2I1 plus V2. So V1 equal to 2 into V2 by 10. So this value of I1 we are getting from this equation, V2 equal to 10I1. So V1 equal to 2 into V2 by 10 plus V2, that is equal to 6 by 5 V2. So A equal to V1 by V2 equal to 1.2. To calculate the value of B and D, we have to make V2 equal to 0. That is, we have to short circuit the output terminals. By short circuiting the output terminals, the circuit becomes this circuit, this network. So from this network, we can write I2 equal to minus 10 by 14 I1. This we are getting by using the current division rule. Here I1 is the main current, I2 current is flowing through the 4 ohm resistance, and I1 plus I2 current is flowing through the 10 ohm resistance. So I2 will be main current divided by total resistance into 10 ohm resistance. So I2 equal to minus 10 by 14 into I1. Here I2 is taken as negative because as the output port is short circuited, the direction of the I2 is opposite. So D equal to minus I1 by I2 equal to 1.4. So from this figure, from this network, we can write V1 equal to 2I1 plus 10 into I1 plus I2. V1 equal to 12I1 plus 10I2. V1 equal to 12 into, in place of I1, it is written minus 14 by 10 I2. This we are getting from the above equation, I2 equal to minus 10 by 14 I1. So V1 equal to 12 into minus 14 by 10 I2 plus 10 I2. So B equal to minus V1 by I2, that is equal to 6.8 ohm.